On July 25th, 1978, in the northwest of England, a baby was born. On its surface, that's not that big of a statement. Babies are born every single day. But this birth was different, attracting media attention from around the world. The baby's name was Louise Brown, and she was the first baby born from in vitro fertilization, or IVF. Welcome to today's episode of Tiny Matters. I'm Sam Jones, and I'm joined by my co-host, Deboki Chakravarti. Today, we're actually answering a question that came to us from Tiny Matters listener Lorraine, who originally asked, how on earth did they come up with IVF? She sent it in for our Q&A episode a couple months ago, and we thought it was a great question, but that it was going to take more than a few minutes to answer. So we decided to dedicate a whole episode to the history and science of IVF. We'll be talking about how IVF works, some of the research that made this treatment possible, and the ways scientists and doctors have been able to improve upon IVF.
Some of our younger listeners might disagree, but 1978 was not that long ago. When I think about it, it's weird to realize that this technology that feels like a relatively common procedure today and plays such an important role in helping families is really only about a decade older than Sam and me. And at the same time, as we've seen this year with the Alabama ruling around IVF and its fallout, IVF faces plenty of challenges that go beyond the scientific principles underlying it.
IVF belongs to a larger class of treatments called assisted reproductive technologies, which is a broad term that can have different definitions. The Centers for Disease Control and Prevention, or CDC, defines assisted reproductive technology as any fertility-related treatment that involves working with eggs or embryos.
And there are a number of reasons today that people might turn to IVF. They might be having trouble conceiving. They could be dealing with the effects of other medical treatments that can cause infertility, or contending with genetic issues that make the ability to screen embryos important, or they may be a same-sex couple.
IVF can provide a lot of hope for patients, but it can also be a very consuming process that asks a lot from them because of the medication and surgery needed to retrieve eggs and then later implant an embryo. When people talk about IVF, you might hear the word cycles. A cycle of IVF will usually last around 2 to 3 weeks, and there are 3 key steps involved in getting from egg to embryo.
And so the 3 steps are really stimulation of the ovary to get more than one egg, bring the egg and sperm together for fertilization, and then grow the embryo in the laboratory to a stage at which we would transfer it to the uterus.
That's Marcelle Cedars, the director of the Division of Reproductive Endocrinology and Infertility at UCSF School of Medicine. You'll hear more from her in a second.
To understand more about how IVF labs make these steps possible, we talked to Sangeeta Jindal, a professor and IVF laboratory director at Einstein College of Medicine in New York and Montefiore's Institute for Reproductive Medicine and Health. She's also the immediate past president of the Society for Assisted Reproductive Technology.
So we know that patients establish relationships with their physicians. It's the physician that is the face of the practice. They are the ones who are treating the patient directly. But really, to me, the laboratory is the engine that drives the car. It is the engine that drives the program. It's a very tightly controlled environment for the growth of these eggs and sperm and embryos. You know, these gametes and embryos do not have immune systems, and we have to make sure that the laboratory can support optimal growth with minimal stress.
So now that we've gotten a bit of a sense for the big picture behind how IVF is done, let's get into specifics. As Marcelle mentioned, the first step is all about the egg, or really we should say eggs. During a normal menstrual cycle, the body typically ends up making a single egg. But with IVF, doctors and scientists want to be able to increase the chances that they'll be able to get a good embryo. And one way to do that is to stimulate the ovaries to make more eggs.
So that means for 10 to 12 days, women are typically on injectable medicines, and these are, for the most part, injectable, small little needle-like insulin just under the skin. The main hormone in those medications is something called FSH, or follicle-stimulating hormone. The pocket of fluid around the egg as it matures is called the follicle. So follicle stimulating hormone stimulates those little eggs and gets them to grow to maturity.
Over those 10 to 12 days, doctors continue checking on the patient to see how the eggs are maturing. They can do this with ultrasound and by tracking hormones produced by the follicle. And when the eggs are mature, they'll give a trigger shot that sets off the final maturation so they can go in and retrieve the eggs.
And nowadays, egg retrievals are done by ultrasound guidance. Initially, they were done by surgery through what's called a laparoscopy, where you'd put a scope into the belly and look at the ovaries. Now we use an ultrasound that goes through the vagina. The needle goes through the wall of the vagina that doesn't have a lot of nerve endings into those follicles, those pockets of fluid. We aspirate that fluid back. And the egg itself is microscopic, so the lab looks under a microscope to find the egg.
The egg retrieval usually takes about 20 to 30 minutes, and there are some risks of bleeding and infection similar to other procedures. And of course, now that we have the egg, the next step is to fertilize it by combining it with sperm. After the egg has been fertilized, it needs to be given some time to develop as an embryo.
And today, most of the time, we grow the embryo to what's called the blastocyst stage. The blastocyst stage is the first time that the embryo starts to sort of separate into different functions. And so there's what's called the inner cell mass, which will ultimately become the baby, and the trophectoderm cells, which will ultimately become the placenta. And that takes about 5 to 6 days in the laboratory. And as a sign of how relatively inefficient that is, that whole process, on average, about 60% of the eggs we retrieve will fertilize. Of those, depending on the age of the egg, because that's one of the strongest drivers for success, about half of them will make it to what's called the blastocyst stage.
At this stage, a few things can happen. For some patients, it might make sense to do pre-implantation genetic testing, where a small sample gets taken from the embryo to look for any chromosomal abnormalities. Or they might have their embryos frozen. Or, of course, they might go through embryo transfer, where a catheter and syringe are used to get the embryo to the uterus, where it will hopefully implant and lead to a successful pregnancy.
Every year, more and more babies are born via assisted reproductive technologies, and IVF remains the most common of these procedures. In 2021, the CDC estimated that about 2.3% of infants in the U.S. were conceived using assisted reproductive technologies, and that the use of these technologies had more than doubled from the previous decade. In 2023, the International Committee for Monitoring Assisted Reproductive Technologies estimated that since 1978, at least 12 million babies around the world had been born via these technologies.
But it wasn't always like this. If we look back to the middle of the 20th century, when IVF was being developed, expanding the ways that people could become pregnant didn't strike everyone as a goal worth pursuing.
It's now so common that it's hard to think ourselves back to a time when people were debating whether or not this should be done at all. I mean, in the 1970s, infertility still had low priority in medicine. I mean, some might say that it still does, but it had a much lower priority then, especially perhaps among the reproductive biologists who were most involved, because many of them were being funded by population control organizations, basically to produce fewer people.
That's Nick Hopwood, a professor of history of science and medicine at the University of Cambridge. But while there may have been a contingent of people who didn't see the need for things like IVF, there was still plenty going on to set the stage for both the scientific and social questions that would emerge as IVF became an increasingly likely possibility. One of the precursors to IVF was artificial insemination, or donor insemination. Going from artificial insemination and the burgeoning understanding of how to work with eggs and sperm and then jumping to in vitro fertilization required a lot of work. And in the mid-1930s, a physiologist named Gregory Pincus claimed to have successfully carried out in vitro fertilization in rabbits. But Nick told us that eventually scientists started to doubt that his results were actually due to fertilization of the rabbit eggs in vitro. It could have been that the unfertilized egg and sperm had just been stuck together before transfer, and then the fertilization happened in vivo, meaning it just happened then in the rabbit. In the mid-1940s, scientists Miriam Menken and John Rock claimed to have fertilized human eggs, but their work was also later called into question.
In 1959, reproductive biologist Min-Chui Chang, who is also Pincus's colleague, was able to demonstrate the first successful IVF in mammals, using rabbits. And as scientists continued testing IVF in different animals, it was controversial to what extent in vitro fertilization had been or should be performed in humans.
At the end of the 1960s, gynecologist Patrick Steptoe and physiologist Robert Edwards began working together, along with a nurse and lab technician named Jean Purdy. Steptoe pioneered laparoscopy, the procedure that uses a small camera to see into the belly and ovaries. And his clinical experience was immensely valuable to Edwards, who'd been studying egg maturation. In 1969, they succeeded in what is now generally seen as the first reliable demonstration of the early stages of in vitro fertilization of human eggs.
These results were a very early step towards an IVF pregnancy, but it was still exciting. It also raised a lot of questions for both the scientists involved in the research and for others who were concerned about what could potentially go wrong.
Now, one of the challenges is the question of safety, because Edwards himself is a bit worried at first. He says and is quoted in various articles as saying, the last thing we want to do is start producing abnormal children because, maybe the procedure will somehow cause problems. He's certainly not the only one who has safety concerns.
These concerns were part of why the UK Medical Council refused to fund the work in 1971, though Edwards and Steptoe were able to get funding in part through private sources. So once Edwards was able to reassure himself of the safety of IVF, the next step was to use their knowledge to fertilize eggs and study how to implant embryos.
And they do that in volunteers, where Steptoe is based in Oldham near Manchester. And, initially they think they might be able to do this in a couple of years, but it takes, they start in 1971, it takes until 1978. It's a lot of trial and error. Edwards working very closely with Jean Purdy, his assistant from Cambridge, and Steptoe and a whole team of nurses and other physicians who are looking after the patients.
Their first inkling of success came in 1976, but this unfortunately turned out to be an ectopic pregnancy, where a fertilized egg grows outside of the uterus, typically in a fallopian tube. If allowed to continue growing, the fallopian tube may burst, causing fatal internal bleeding. So one of the major changes that the team ended up making was to actually stop trying to stimulate the ovary into making a bunch of eggs. Instead, they had the volunteers return to their natural cycles, even though this meant that they could only retrieve one egg each cycle. About 2 years later, in 1978, Leslie Brown gave birth to Louise Brown.
In talking to us, Nick really emphasized the contributions of volunteers like Leslie Brown to making IVF possible.
They're all hoping that they might get pregnant, but they went through a lot of procedures, a lot of hopes raised and dashed before Leslie Brown was the lucky first woman to become pregnant by in vitro fertilization. So I think it's important, partly because IVF is often presented, or used to be presented quite often, as a technology developed by this couple of men. I mean, not only did Jean Purdy play an important role, but the patient volunteers, and then a whole team of nurses who put in countless hours of overtime looking after the patients. And so this was really a team effort.
We'll return to talking about IVF in a moment, but first we'd like to tell you about another podcast we think you'll love. It's called Strange by Nature, and it's a science-based weekly dive into the strange side of the natural world. Strange by Nature is hosted by 3 professional naturalists. Each week, Kirk, Rachel, and Victoria bring stories from around the world and, once in a while, even from other planets. They talk about everything from brain-eating amoebas to flying snakes and all of the strange things in between.
Truth is often stranger than fiction, and we live on an endlessly fascinating planet where we can ask, how and why did tongues evolve? What cologne did tigers find most alluring? Why does Australia seem to have so many deadly animals? Want answers? You'll have to listen to find out. New episodes of Strange by Nature drop every Wednesday, so why not check it out and get your weekly dose of weird? All right, back to the episode. Since 1978, many research advances have made IVF more successful. In the UK, the success rate was around 6% in the 1990s, and by 2021, that rate was up to 27%. Keep in mind that people's individual rates of success are dependent on a whole host of factors like age and other conditions. One thing that's helped is that while Edwards and Steptoe ended up working with volunteers' natural cycles, doctors and scientists soon went back to stimulating the production of more eggs for a successful IVF.
And Sangeeta told us that another major advance was in the handling of sperm, and particularly a technique called ICSI, or intracytoplasmic sperm injection, which involves injecting sperm directly into the egg.
And that just means we can treat couples with male factor who do not have sperm that are enough or swimming quickly enough or have some kind of morphological issue where we know that's associated with reduced fertilization on their own.
Another advance that you might not immediately think of is the ability to freeze eggs.
The egg freezing has really come a long way. It was the most challenging type of technique. We could freeze sperm for years, but we could never freeze eggs, and that's only come on in the last maybe 10, 12 years.
There's lots of cytoplasm, and if you're trying to freeze it, you're going to get ice crystals. And those ice crystals, when they form, they can damage the egg.
That's Emily Youngheim, a physician and division chief of reproductive endocrinology and the medical director of the Center for Fertility and Reproductive Medicine at Northwestern Medicine. The process that made egg freezing possible is called vitrification, and it involves rapidly cooling the egg with liquid nitrogen.
And so that made egg banking possible, not just for folks who were facing sterilizing treatment, not just for folks who were concerned about having embryos in storage they weren't going to use, but also for women who recognized, gosh, age alone is going to make it so that I have a difficult time getting pregnant down the road.
Labs also got better at culturing these embryos, which had important consequences for how doctors could approach implantation.
So when IVF was first introduced, really the hard part of it was getting embryos to grow well in the lab. And we certainly couldn't freeze back in the day when it first came out. And so to overcome that and improve the efficiency of IVF and its effectiveness, oftentimes we were talking about transferring back multiple embryos. And at the time, that's where IVF really was getting a bad name, was causing multiple gestations and sometimes what we call higher order multiple gestations like triplets and quadruplets.
As culturing techniques have improved, labs can now let embryos grow a few more days before transferring them to patients, giving them time to see which embryo might have the highest odds of success.
Despite the fact that IVF has improved a lot, there are still some major limitations to success, and one of the big inescapable ones is age. In 2021, the CDC reported that for patients under the age of 35 who were using their own eggs, around 50.7% of all cycles were successful, meaning there was a live birth delivery. But for patients between the ages of 35 and 37, that went down to 36.3%, and for patients between 38 and 40, it went down to 23.3%.
And while there have been major advancements in IVF, some of those advances come with their own questions. For example, pre-implantation genetic testing may seem like an obvious choice that should be able to improve the odds of success for IVF. But as Marcel told us, the information provided by these tests can be difficult to navigate.
We still don't know which couples are helped the most. We think it probably makes more sense in women who are older, where the genetic risk is higher. The problem is women are born with a finite number of eggs, and we use them up throughout our lifetime. So as women get older, not only does the quality decline or the genetic risk goes up, but also the quantity decline. So if you have a very few embryos, the people who maybe need it most and could benefit the most might be the least able to take advantage of that.
And related to this is an even more fundamental question: who can access IVF? In some countries, IVF is covered by national health insurance, but in the US, it can really come down to what state you live in and what kind of health insurance you're able to get.
I came to Northwestern in 2020, right before COVID started. But before that, I was at Washington University in St. Louis, which is an awesome place to practice, but it was in Missouri. And there was no mandate in Missouri to cover IVF. So if you had employer-based insurance, whether or not you had coverage was variable, and most people didn't. And so if they were doing IVF, oftentimes they were paying out of pocket. In Illinois, there is a mandate for employer-based insurance to cover IVF. And I will say, practicing in Illinois is a lot different than it was practicing in Missouri. A lot of times if somebody came to me to do IVF, they may be able to afford going through only once. But we know just based on this technology, and it's great technology and it works really, really well for a lot of people, but oftentimes you need to go through more than one retrieval to have a successful outcome. If you're paying out of pocket for that, it could run anywhere between $12,000 and $20,000, depending on how much medication you need and whether or not you're going to apply genetic testing to that cycle. So it is really pricey.
We can see the impact of IVF most obviously in the families who were made possible thanks to the treatment. But Nick reminded us that IVF is about more than just IVF.
One of the important things about IVF is that it is a fertility treatment, but it's also been a platform for a whole host of other assisted reproductive technologies, for the making of human embryonic stem cells, research in human developmental biology. So there are a lot of lines that radiate out from these innovations. One of the most controversial topics has been research on pre-implantation embryos. And I mean, this is essential to keeping IVF going, as well as improving it and learning about human development. But it's been much more controversial than the fertility treatment itself. And in the 1980s and since, this has been much debated, what should be allowed and so on.
Nick told us that in the UK, lobbying by scientists, doctors, and patient groups led to the passage of the Human Fertilization and Embryology Act in 1990, resulting in research that is highly regulated but allowed on embryos up to 14 days after fertilization. But in the US, we've had a more complicated history of regulating this kind of research. One of the key moments in that history is the passage of the Deboki Amendment in 1996.
And basically, that law said that the government could not fund any activities that involved human research or creation of embryos or destruction of embryos for research. And the Deboki Amendment has been renewed every year with every budget bill. It gets renewed. And so it's really obstructed progress. We could have been leaders in this field. And I think it's also hurt our field in the current iteration of IVF in research, because people are leaving academia and have over the last decade or two who do IVF, because part of staying in academia is to be involved in research. And if you can't do research in these areas, and the only way you can do it is with private funding, then it makes it easier to make an argument to leave academia and not to be involved in trying to get national, federal funding for this research. So it hurt our field not being at the lead in terms of IVF. And I think it hurts us now being at the lead in terms of innovation.
I know that's sort of a frustrating note to end on, but one of the things that I kept thinking about while working on this episode is how even with these historical fears about how reproductive technologies like IVF might turn reproduction and pregnancy into a mechanical process, there's so many ways in which it hasn't. Pregnancy is such a long and personal process no matter how someone becomes pregnant. And for the people working in this field, that means the science is being carried out alongside a lot of care for the patients.
I think it's hard when things like the Alabama story come out, and a lot of times when we talk about IVF, it's because there's been some story of something horrible happening, an embryo mix-up or lost oocytes that have been in a cryo tank and the cryo tank fails, or someone making a statement or a decision that's really misinformed. But by and large, at the end of the day, what we do is pretty darn amazing. It's incredible to be able to help someone become a parent and have a healthy child. It's darn amazing.
Let's do some tiny show and telling.
I can go first because mine is like a supplemental information.
Yeah, that sounds great.
So Sam, for my tiny show and tell, I'm basically here because this episode working on it was like super fascinating, but it was also tough because there were so many things that I wanted to get a chance to talk about, because there's so many aspects to the history of IVF and how it works and everything that is super fascinating. But obviously we're not here to talk forever about topics we find interesting. So I wanted to take advantage of my tiny show and tell to actually share a paper that I think covers a really interesting and important part of IVF history. documentary, which is a paper called Looking into the Test Tube, The Birth of IVF on British Television, which was written by Catherine Dow and published in 2019. So this paper is about a British television documentary that was broadcast 6 weeks after Louise Brown's birth. And the paper looks at both how this documentary was made and its role in the conversations around IVF at the time. So the reason why I think this paper might be worth reading if people are interested in more about the history of IVF is one of the topics that kind of came up in my conversation with Nick is the role of the media in kind of shaping this debate and how Steptoe and Edwards sort of thought that basically involving the public in these discussions around IVF was important. And so I just think it's super interesting for anyone who likes to get meta about their science communication and to kind of think about the role of media in shaping these conversations around science.
That's fascinating. I'm so curious to see how it was shaped both in ways that were beneficial and not so beneficial. But yeah, absolutely. I mean, we see it in everything. And I feel like right now, we won't get into it, but media definitely shapes a lot of conversations going on specifically about reproductive health right now in this country. So fascinating. So what I want to tell you about is an unexpected discovery of a fossilized skull of a 270 million year old ancient amphibian ancestor that was just hanging out in the Smithsonian National Museum of Natural History's collections.
Just chilling.
Yeah, just chilling. For a while, in fact. The skull was actually originally found in this rock layer in Texas called the Clear Fork Formation. And it was found in 1984 by the late paleontologist Nicholas Haughton III. And so Nicholas Haughton III, he was the curator in the museum's paleobiology department for nearly 40 years. And he and his team collected tons and tons of fossils in that time, so many that they couldn't study all of them in detail. And so this little skull sat in a fossil collection for nearly 40 years until it caught the eye of a researcher. What they saw was that the skull kind of possessed this really interesting mix of traits that were different from the features seen in the skulls of older tetrapods, which are the ancient ancestors of amphibians and other four-legged vertebrates. So for example, the part of the skull behind the animal's eyes was much shorter than its elongated, curved snout. And the idea is that those proportions would have actually helped the animal, who might have had a snout that kind of looked like a salamander's, be able to snap up grub-like insects. What they were able to figure out based on these features was that this fossil was part of a diverse group of primitive amphibian relatives that lived for over 200 million years around the Carboniferous to Triassic periods. But because of this interesting group of features, they couldn't really assign it to any genus that currently exists. And so what they did was they actually created an entirely new one, which they named Kermitops. So this amphibian ancestor is named Kermitops gratis in honor of Kermit the Frog.
Oh.
And I didn't realize this, but the amphibian family tree just isn't very well defined. And so having this skull that is from something that lived likely 270 million years ago is a very interesting and important link in understanding the evolution of these animals.
Wow.
Yeah.
And they just found it in their archives.
Yeah, it's just it was hanging out under our noses for almost 4 decades. And then someone's like, that's interesting. That kind of looks like an amphibian that we know today, but also not. And
I'm also surprised that we haven't seen many amphibians named for Kermit already.
I know. That was a missed opportunity for so long. I'm so glad that these guys decided it's time.
Yeah, it seems like they were ready.
They were ready.
When we find our next amphibian, it's going to be a Kermit homage.
Thanks for tuning in to this week's episode of Tiny Matters, a production of the American Chemical Society.
This week's script was written by me and was edited by Michael David and by Sam Jones, who is also our executive producer. It was fact-checked by Michelle Boucher. The Tiny Matters theme and episode sound design are by Michael Simonelli and the Charts and Leisure team.
Thanks so much to Marcel Cedars, Sangeeta Jindal, Nick Hopwood, and Emily Youngheim for joining us. If you have thoughts, questions, ideas about future Tiny Matters episodes, send us an email, tinymatters@acs.org. You can find me on social @SamJScience.
And you can find me at Okie Dokie Boki. See you next time.